Hi there, I'm Dr. Koenig, and this is a second video on solving equations with rational numbers. This video is the second in a series of videos that cover rational number equations. In the first video, if you haven't seen it yet, I solved one-step equations, so we're really focusing on one step that will isolate a variable entirely. Now this video really builds on it. This video is focused on two-step equations, so if you haven't yet seen that video, I would suggest you start there. Now the whole idea of solving an equation is to isolate the variable. So when you see something like this is a general two-step equation, I would suggest a couple of steps to get you started. First, find that variable, and sometimes it helps to circle it. We also, in my classroom, tend to put a line down the equal sign. That helps us to see clearly that there are two sides of an equation that we're balancing. Whatever happens on the left side of that line needs to happen on the right side as well as we go along. Now, in order to isolate my variable, I need to first remove anything with a plus or a minus. So I'm going to start with that plus 3.8. As you might remember from solving equations prior to rational numbers, you need to use an opposite operation. In this case, the opposite operation would be to subtract 3.8. Now again, I'm doing the same thing on the left side as I did on the right side. That helps to keep my equation balanced. Now, on the left-hand side, because I had a positive 3.8 and a negative 3.8, 3.8 minus 3.8 is 0, which means I have removed that constant number, and I'll bring down my negative 2.5m. On the right-hand side, I have negative 16.2 minus 3.8, which can look a little tricky. If it helps, you can change it to negative 16.2 plus negative 3.8. Either way, you should end up at negative 20. Now, to complete the process, we now have a second step, hence the two-step equation title on this page. In order to get m by itself, I need to remove that negative 2.5. It can be really tempting to add it to both sides. We just said that a positive and a negative were opposites. However, in this case, if you don't see a symbol in between the variable and the number, what's really happening there is you have negative 2.5 times m equal to negative 20. And in order to undo multiplication, we use its opposite operation, which is to divide by 2.5 on both sides. Now on the left-hand side, negative 2.5 divided by negative 2.5 is 1. So I'm left with 1m, or just m. On the right-hand side, I need to contend with 20 divided by 2.5, which can be a little tricky. Now, as you're solving that, it's okay to go off on the side and say, I'm dividing 20 by 2.5. I'm even leaving off the negatives. I'll come back to those later. I just want to figure out what this problem would give me. Now, it's also okay to take both of those numbers when you're working with decimals and multiply them by 10. What that gives us is an expression that looks a little bit different, but it solves and gives you the exact same value. So it's an equivalent expression. It just looks a little different. Now, once I've done that, I can divide 200 by 25, and I know the answer to that is 8. So I want to go back to my problem and realize that I was dividing negative by negative, so I end up with positive 8 as my solution. This problem is similar. I've thrown in a fraction, but otherwise we're using the same ideals as we solve. So the first thing I want to do is find the variable that I'm trying to isolate, and I also find it really helpful to put that line down the equal sign. Again, that reminds us that there are two sides that we're trying to balance, and anything that I do on the left, I have to do on the right as well. To get started, I need to remove that negative 4.7 or minus 4.7, and I'll do that by using a plus 4.7 or a positive 4.7, and again, I'll do the same thing on both sides. Now, I know that negative 4.7 plus 4.7 is 0, so that essentially removes that term from the left-hand side. Now I'm left with negative 3/4 p, and on the right-hand side, 10.3 plus 4.7 is 15. Now, in the last video, I covered a different strategy for solving fraction problems. This time I want to show you something that's a little more efficient, a little more straightforward. Now, as we discussed in the last problem, if there's a number next to a variable and there's no symbol in between, what's really happening there is multiplication, and it's okay to put a multiplication dot to help you remember. Now, to undo multiplication, we would typically divide, but let's go off to the side and remember how we divide by a fraction. let's say we had, for example, 3/2 divided by 5/4. In order to divide by a fraction, we learned early on in middle school that you actually can take that second fraction and reciprocate it and multiply. So when you see a division problem with fractions, you can actually multiply by the reciprocal. In this case, we would get 12/10, which is the same as 6/5 fully simplified. Now, back to our problem. If I'm trying to divide by -3/4, I will end up multiplying by the reciprocal. So that's the step I want to show you today. I'm going to multiply both sides by -4/3 and show you how that works in a problem. It's a little more efficient than the strategy I taught you last time. Neither is more right or more wrong, but sometimes it's nice to just get to the point once you kind of understand how to work with fractions. Now, on the left-hand side, we end up with 12/12p, which, as we know, is equivalent to 1p, or just p. On the right-hand side, we'll need to turn that 15 into a fraction, and we turn it into a fraction by putting a 1 underneath it. That allows us to multiply straight across. So 15 times -4 is -60, 1 times 3 is 3, and -60/3 simplifies to -20. Now, there isn't one perfect thing I can tell you that will help you to solve every equation you ever come across. However, the big idea here is that equations with fractions and decimals are solved just like equations with whole numbers and just like equations with integers. You have to use opposite operations. Your goal is to isolate the variable, and whatever you do on one side of the equation, you have to do on the other side of that equal sign. Now, there are strategies that can help, and I hope this video gave you some to pull from when you're solving challenging equations with fractions and decimals within them. Just like always, thanks for being here. I'll see you next time.